Hi, Bhaskar here. Today we are going to talk about what is the effect of sample diluent on the chromatographic peak shape. And I am going to speak in the context of reverse phase chromatography. We very well know that the importance of Gaussian peak shape for better resolution and the quantitation. But in case if you choose the stronger organic solvent as your diluent, for example, you are using a mobile phase of 70% methanol, and if you use 100% methanol as your sample diluent, you may see distortion in the picture for your analyte. And the degree of distortion will be much higher in case if the retention time is lower because your solute molecule will travel along with the diluent and it will have less amount of interaction with the column. You can see the similar kind of scenario into the diagram over here. The solute molecule is traveling along with your sample diluent and it end up with the high distorted peak shape. Similarly, in case if you are using a stronger organic solvent as a diluent, I mean your diluent is stronger than your mobile phase. And in case if the analyte is having the higher retention time, then the chances of distortion is minimum. The reason is your solute molecules will come out of your diluent because of its high interaction with the stationary phase. Now look at the screen and you will understand what I mean. So the sample diluent may not influence the peak shape of the solute because the sample diluent is far away from your actual solute molecules. And because of that, you may get a good peak shape even though your solvent strength is much higher as compared to the mobile phase strength. Now it has been said that you need to have a diluent with the similar strength as that of your mobile phase, or the difference between viscosity of diluent and mobile phase must be minimum. So let us understand with the help of some examples why this is so. It has been widely advised the use of the mobile phase as injection solvent, avoiding the use of solvent stronger than the mobile phase. Similarly, the intensity of the peak broadening or distortion is depends on the degree of viscosity mismatch between solute and the mobile phase. So let us prove these two important statements with the help of further examples. Now assume that you are running a chromatography with the mobile phase as the 70% ACN and you are going to keep another parameters equal and the same. In the first experiment, you have used your mobile phase that is 70% ACN as a sample diluent and out of that you have got a very beautiful Gaussian peak. In case if you use organic solvent or pure organic solvent as a diluent, you can see distortion into the peak shape and same can be seen onto the screen over here. You will see that the distortion is much severe in case of stronger organic solvent like 100% IPA. The distortion of peak shape will also depend on to the injection volume. Higher is the injection volume, higher will be the distortion into the peak shape. So this proves that the peak shape get distorted because of the use of stronger solvent or pure organic solvent. Now in this case, you have used the isoelotropic diluent. Now what is meant by isoelotropic diluent? Now these are the diluent which has similar strength in terms of their retention into the reverse phase chromatography. That means, for example, your mobile phase is 70% methanol And if you say that the 60% ACN is the isoelotropic diluent, this indicates that you will have similar kind of retention time by using both of these mobile phases. Similarly, if I say that the 50% THF is also isoelotropic diluent with 70% methanol, that also indicates that these two different mobile phase ends up in the almost similar retention time for the given analyte. That is the definition of isoelotropic diluent. This also proves that now they are in the similar strength as they are having the equal retention time. That also indicates that their strength are similar. So 70% methanol is equal to 60% ACN, or 70% methanol is also equal to the 50% THF. Now when you run the chromatography with mobile phase, that is 70% methanol, you also use your mobile phase, that is 70% methanol, as a diluent. See the peak onto the screen. Now there is the another peak with the dark dotted line. In case if your mobile phase is 70% methanol, but your sample diluent is 60% ACN. Now can you see whether there is a distortion in the peak shape or the peak shape is perfectly alright? Here you only try to match the strength of the diluent and your mobile phase, and you have resulted into the very good peak shape. The same kind of observation can be noted even with 50% THF as a diluent. The reason is their strength is one and the same. And hence, you can conclude that in case if your diluent and mobile phase strength is closer, no peak distortion will be found. Distortion is not common for analytes with higher retention is another important point you must consider. The second important point is about the viscosities now. In the first example onto the left side of the screen, your mobile phase is 50% acetonitrile with the viscosity of 0.82 cp. Your diluent is isoelotropic, means having the similar strength but with the viscosity of 2.1 cp. Now, in the earlier example, let me go back just. We said that if we match the solvent strength and the mobile phase strength, our peak shape is going to be fantastic. But in this case, even though they are isoelotropic, 50% ACN in 30% IP are having the equal strength, but look at the peak shapes. Are they acceptable to you? They are not at all. Now you may be thinking that this may be the reason because my mobile phase viscosity is lower than the diluent viscosity. But look at the right side onto your screen where your mobile phase is 30% IPA and diluent is 50% ACN. Now in this case, mobile phase is having much higher viscosity than the diluent. But still, you will find that the peak shape with the 50% ACN is very much distorted. So what is the reason behind this distortion? Now we cannot reasoning with the solvent strength, because in each example you have actually matched the solvent strength with your mobile phase, but still your peak shape is distorted. So you can attribute this finding to the viscosity mismatch. Your viscosity of mobile phase and viscosity of diluent is having a huge difference, and because of that you are getting the distorted peak shapes. In case if you reduce the viscosity difference, and here is the example onto your screen, the diluent and mobile phase are having almost similar viscosities. Mobile phase is having the viscosity of 0.75 cp, and sorry, the mobile phase is having the viscosity of 0.722 cp, which is 60% ACN. And look at the peak. You got a very beautiful peak just by using this diluent as a mobile phase, which is quite acceptable or expected. But look at the dotted line chromatogram over here with the 90% THF, but having the similar viscosity of 0.75 cp, which is very close to your mobile phase viscosity, which is 0.72 cp in this case. And you will find a beautiful peak shape for this kind of diluent having almost similar viscosities. So what is the learning? No peak distortion is observed with almost similar viscosity of diluent and the mobile phase. Peak is slightly wide when they are dissolved in a strong solvent like THF. You can see a little fronting to the peak shape, but it is because of the THF as a which is a very strong diluent. But overall, the peak shape is very much acceptable. The important points that we must consider: preferably use mobile phase as a diluent. In case if you are not able to use mobile phase as your diluent, keep diluent strength close to mobile phase or if possible little less than the mobile phase strength. Keep viscosity of diluent close to viscosity of the mobile phase. Finally, if the sample viscosity is higher or lower than the mobile phase viscosities, you must try to maintain the difference of not more than 10%. The diluent or mobile phase viscosity can be modified by the addition of an additive in order to satisfy the viscosity requirements. So next time when you are planning for the method development, also look at the viscosity difference between diluent and your mobile phase. Probably this could be the reason for your distorted peak shape um, that you are looking at the chromatograph. Thank you so much for watching this video, and I will meet you soon with such kind of very useful and informative videos. Till then, take care and bye bye. See you soon.